Okay. I see a comment down here. Can I make something? I think that was related to the exam earlier, so I'll delete that comment. Okay. So we're going to have a relatively short day today for two reasons. One is we don't have that much left to cover, and the second reason is uh, I'm kind of losing my voice, as you can probably tell. I don't know. I've got some kind of a spring cold. Seem to be doing okay in the morning, and then in the evening I kind of start running a little fever. It's a really strange type condition. So hopefully, hopefully it'll leave me pretty soon. I did just get back from an award ceremony in which Miss Kim Land won the Faculty and Advisor of the Year. So we're very proud of Miss Land for winning that award. She deserves it immensely. Okay, so continuing on with wireless, let me get my little drawing pin up here. There it is. So, cellular encoding, what that means is, now I think we've talked about this. I just want to cover it. Encoding means how is the signal scrambled. Now, with the way you recommend signals, whether it's on wire or it's in the airwaves, is you have energy waves that are propagated through space or they're propagated over a wire that has an electrical current on it. So TDM is what's called time division multiplexing. So you have hardware on the phone and the receiver, which would be on the antenna, that has a pattern of encoding that it recognizes. So, for example, this would be one frequency, and then there's a space. So this is user one, and this would be user number two. That was not very good. Need to make sure we got a consistent line there. So this would be user number two with a lower frequency, and then user number three would have a very high, a higher frequency, and they have, it's a point. Each user is allocated a slice of time, and in that time they can put as much data on, as their particular frequency will allow. Now, there's frequency division multiplexing, which means you have subbands that have separate signals. So maybe you have one channel. Think of it like channels that is this frequency, and then you have another channel that is a higher frequency. And so you have data being propagated on both channels. That's two channels. And then you also have technologies like long-term evolution, which combine frequency division multiplexing with time division multiplexing. So you have multiple channels, varying frequencies on each channel, and in order for your phone to work on that network, your silicon technology has to match your the antenna you're connecting to, and the technology that company is actually using. There is a convergence on the long-term evolution standard. By the way you represent ones and zeros, just to remind you. I see that Carson has raised her hand. What do you want, Carson? If you have a microphone, Mark Carson, I think you can talk. You can ask a question. Oh, thank you. Sorry about that. Share my screen. There you go. My throat is so dry. Whew. So there are just different ways of encoding data. And the way, but whether it's on a line or whether it's in the air, if you have a peak in a sine wave, it's a 1, a trough is a 1, a peak is a 1, a trough is a 1. Then you have a timing mechanism. So we have, say, 3 zeros here: 1, 1, 1, 1, 1, 1, 1, oops, 1, and then 2 zeros. And that's how you represent binary information when you propagate it over a cellular network. Of course, the sending device and the receiving device have to match. And, providing security, that's a whole other mechanism where you're actually encrypting your data as it's being transmitted. We are in really in the United States. There's discussion about 5G. There certainly are locations where there are 5G installations, but for the most part, a lot of places in the country, you're fortunate to get 3G, which is about 2 megabits per second when it comes to data transfer speeds. 4G is characterized by anywhere from 20 to 100 megs. By the way, if you have a cell phone and you're moving, for those of you who may have noticed this when you're driving down the road, you'll notice that your transmission speed goes down as you're driving. So if you run a test on something like speedtest.net, I think I actually have that in my browser. Here we go. Yeah. So you can see we have a download speed here in the building of around, looks like close to 90 megabits per second, which is pretty good, but there are locations on the main campus where I get around 243 to 300, depending. Upload speeds a little slower. Now, of course, this is the network that the wireless access points in the building are connected to. So every time you add a layer of connectivity like that, you're going to lose some transmission speed in terms of the translation overhead from one technology to another. So if you were to run a test on your wireless device, you would probably find that it is significantly slower. Unfortunately, I didn't bring my wireless laptop or my phone in here. What we're seeing with carriers, however, is the drive to converge technologies so that your voice, video, and data are all propagated over the data network, just like, for example, here at the university, we have local area networks that are interconnected with LAN links, and all of the data, the voice is propagated over the same network infrastructure. This will allow companies to do different things because you won't have a separate phone system that whether it's a wireless company or whether it's a traditional phone company, all the data will be propagated over a data network. And that simplifies greatly administrative overhead. It also simplifies the delivery of services such as having a single voicemail source tied to your instant messaging, for example, a single number that might utilize your cell phone would have the same number as your landline phone would have because they're both on the same network. the fact that cell phones are really mobile and they're just much more powerful, the cell phone really is becoming kind of the center of a lot of users' life. So if you're in the world of business, one platform you'd better not ignore is you'd better not ignore the cell phone, because if you look, for example, at the sales that are being generated over mobile devices like cell phones, smartphones, they keep going up every year. If you look at that Black Friday, Cyber Monday data, in the initially people did not buy things with their smartphones, but their smartphones displays have become so large, and there have been such improvements to the display, the interaction, the applications that allow the use of different services with the transactions, that more and more procurements are being made on smartphones these days. Quickly on satellites, I know we discussed it last time. A satellite is nothing more than a very high tower. Okay, we have terrestrial microwave towers, which have limitations because the surface of the Earth is curved. So if you have a 300-foot tall tower, it's got a range on a prairie in a flat desert. That 300-foot tall tower has a range of about 30 miles. At that point, the curvature of the Earth actually gets in the way of the signal from one point to another. So you either have to build the receiving tower up higher to elevate itself above the curve, or you need to have an antenna up in the sky, which, again, a satellite is merely mankind taking advantage of the fact that we have a planet that operates in space, and if you put an object up there with the appropriate navigational equipment and power source, you can maneuver that object very precisely, very exactly. Or you can lock it into orbit. If you put it up around 22,250 miles up, or roughly that, above the equator, it will stay right there. It will lock itself in orbit. And you really don't have to navigate it that much. It's called a geosynchronous orbit. The downside of being 22,000 miles up is it takes quite a while for a microwave signal to get up to relatively speaking, of course, to get up to the satellite and then back down to the corresponding ground source. So if I'm browsing the internet, for example, and I want to access a resource, so I send a request to a server. It goes up and back down. It takes roughly 4.5 to 5 seconds delay time. And then the information is propagated back up and then back down. That's another 4-second delay time, so it's about 8 seconds. Now, once I start downloading, if I'm just downloading data, that's relatively fast. If I'm doing it one directional, which is what you do when you're watching TV, direct TV, you're streaming data down. So when you access and request a movie, you're streaming that data down, and that data is constantly streaming down to your satellite, which is, or to your satellite on your home or mounted on a stand. So if you're a DirecTV or a Dish Network customer, that data is constantly coming down. So when you turn the system on, you're just turning it on a stream of data. And it's one directional. Of course, it's streaming one way. The satellites, even today, relative to the kind of speed you get from terrestrial systems, are not, they don't really have the capacity. And it's mainly a factor of cost of building those devices that can propagate, that have the transponders that have that kind of data transmission capacity. Although the nanotization, the miniaturization of these devices is making vast improvements. So here's a link to, and this was published in 2016, and this is there's discussion of putting one terabit per second satellites. And it's a company called Viasat, and so they plan to offer residential connections. I need to follow up and see whether or not they did this. Unfortunately, it didn't tell us exactly how high up these satellites actually were. there have been different novel approaches. Google tried to create a model that actually used balloons, which was an interesting concept. So again, the miniaturization and improvement in technology is certainly going to make satellite competitive. The downside of satellite, of course, is it's expensive to service your towers. They're not right there where you can drive a truck. They're up there where you have to send a robot, and I mean a spacecraft, and perhaps use robotics to repair it, or perhaps even a human to actually perform repairs on it, or maybe you just take a new one up and launch it, and replace the old one. These are just some nano satellite companies. In the next 10 years, I believe there have been requests to the FCC, which oversees satellite communications, for the launching of, the placement of roughly 10,000 satellites. So it's definitely taking off. And these are some companies that are their business model is centered around having these satellites, some of them low Earth orbit, some of them geosynchronous, some of them middle Earth orbit satellites. Depends on what their use is for. Skybox is probably, since it's using low cost, high resolution, those are lower Earth orbit satellites. Most of these probably are lower Earth orbit satellites, by the way, because they are nanosatellites. They represent a modest investment. You place them in orbit, they actually revolve around the planet, but you can set up an array of these things where they maintain the appropriate position relative to each other. And, resolutions, high resolution photographs, coupled with software for tracking things or counting things, or just being in the high resolution imaging, where maybe they're being used by nation states for purposes of intelligence gathering or spying, for example. Again, OnWave is a company, I believe it's in Ireland, and OnWave is offering satellite-based broadband services. So 100 megabits per second. Now, of course, satellite is dependent on whether or not you have a line of sight of the satellite. So things like cloud cover, or if you put the antenna in an inappropriate location and springtime comes around and all the leaves block you from accessing the satellite, then that can cause you problems. Global Phone Communications. Iridium is a company. It's a spinoff from a governmental entity. It was created by the military, and it uses relatively low-powered phones to provide global satellite phone communication. So whether you're in the middle of the ocean, on top of a mountain somewhere, as long as you have access to a satellite, an array of satellites, you can initiate a phone call using Iridium. Global Positioning Systems is a relatively new system, again, developed by the military. It's comprised of MEO satellites, that is medium Earth orbit satellites there's 24 of them to cover the face of the Earth. In other words, so that if you need to triangulate your position, whether you're in an icebreaker ship in the middle of the Arctic, or whether you're down in Florida and you have some equipment that is being used and you're using it to survey a piece of land, you need three of those satellites, access to three of those satellites to triangulate a position. And GPS is very accurate. The accurate side of it was restricted from public use for a number of years, but it was used to guide smart bombs. It was said that it could guide a smart bomb to a space about a centimeter, in about a square centimeter, or a round centimeter. So it could drop a bomb in a space about that exact. Of course, now that functionality has been extended to a lot of companies incorporate GPS, as I said, surveying equipment, a lot of construction equipment, earth movers, for example, where perhaps you need to grade along a a property line, or maybe you have a layout for a neighborhood on a piece of property, and this is where the road goes, so you can feed those coordinates into the system and it will actually guide the equipment. There are, the Uber uses GPS. Uber is, of course, the highly successful car sharing model. Uber, there was Uber Black, which Uber owned those cars, and then Uber introduced X12, and that was where Uber hired and created software that somebody who wanted to moonlight as a taxi driver could install that software on their phones, mount it on their screen, and they could provide riding services for someone who was seeking those, and the Uber software would match it up. The Uber server kept track of the latitudinal, longitudinal position of the driver as well as the fare, and it matches up the appropriate resource. GPS does not work as well in cities, and so to compensate for that, Uber used a data derived from a geographic information system that contained the exact mileages, and it uses kind of sophisticated computations, probabilistic computations about when, they generally are going to involve calculus about when a driver will arrive at their destination given their current location or their last known location and how many miles there are between them and their location. If GPS is able, it just tracks it, and it also still performs calculations to give arrival time. Most cell phones today are equipped with GPS chips. They do enable users to be located via software. A lot of software applications that you install will request access to GPS. My advice is to be aware of the fact that a GPS chip active on your cell phone provides locational-based access to the company that you have you've installed that application for. And that is invaluable information. That information can be stored in a database and forever. And it can be sold because it's invaluable. It adds a dimension to you as a consumer, as a citizen that was not there before. This is the person doing this, and this is where they were when they did it, and this is where they traveled. GPS enables there is an insatiable focus on pleasing customers. I was listening to the radio this morning. They were talking about personalization and how companies are really catering to customers and trying to personalize the service or product that they sell to them. And knowing locational information about your customers helps with that personalization. For example, if it's known that you frequent a certain area within a mall, where maybe these are the 2 or 3 department stores that you frequent, well, that's an opportunity to reach out to those entities and perhaps direct promotional material to you. Or sell that information that they have for marketing purposes. So GPS coupled with geographic information system. A geographic information system is nothing more than a digital map. Coupled with a GIS enables the delivery of such location-based services, whether it's advertising, whether it's news and information, whether it's in navigational information, traffic information. If you have, some of you may have this little app on your phone. Do any of you have the Waze application on your phone? Nobody uses Waze? So Waze enables you to locate carpooling, but it also gives you information on traffic. It has a revenue model. Google actually owns Waze, by the way. Um, and of course, Waze shares your locational information. So when you're driving down the road, if there is a traffic event, anyone who has the Waze application installed on their cell phone is feeding data relative to their position, also the speed that they're actually traveling. Um, and that map, that interactive map, is a wonderful opportunity to place advertising links on the map as the car is going by. You can see advertising links on the map, and you can click on those maps and get directed to that location if you're interested in maybe frequenting that establishment. Geographic information systems, what are they? They're digital maps. They make edge matching a lot easier. In the past, when somebody built a map, the map typically covered a particular area. Maybe it covered the United States and part of the Atlantic Ocean and part of Antarctica, and then you needed to map it up to a map of Europe and Russia, and then kind of piece things together. And that's challenging when you're dealing with a two-dimensional map made of paper. Digital maps, on the other hand, make the art of cartography, which is the science and art of making maps, a lot easier, and allows maps to be built to scale. Just to give you an example of how problematic paper maps were, so let's look at a world map. And these are paper maps, of course. And this is something that most people don't know, but if you look at this map, so you'll note that here is Greenland up here, and you'll notice Greenland is kind of the shape of Africa. This is Africa. Well, there's something called the Mercator effect, which there's a guy named Mercator who was one of the first cartographers, and he created maps like there were linear connections between land masses. And it had the effect of reducing the size of particular land masses. So if you look at Africa, especially as you got near the equator, if you look at Africa, it appears that Africa and Greenland, they're not the same size, but Africa is not much smaller than Greenland. Greenland's actually 14 times smaller than Africa. So you could fit 14 Greenlands in Africa. Africa is an enormous continent. And again, just the cause of this is taking a curved model and converting it into a linear one. Let's see. True size of Africa. So here's the true size of Africa. These are all the countries you could put inside of Africa. You could put China in Africa easily, Mongolia. Here's another one. Put the United States, China, India, Eastern Europe, Spain, France, Germany, Italy, Portugal. And what is that? Second part of India, I guess. And the UK fits in the, what is that island off the coast of Africa? It starts with an M. Does anyone remember? Anyway, that island is, Madagascar. Thank you very much, Rachel. I knew it was something. Madagascar is the size of the UK. So this is an enormous island. And again, all of that is due to the Mercator effect. So just some challenges with using two-dimensional maps with linear set with looking at things from a linear position. Okay, so geographic information system. Again, it is a digital map that has spatial data, and that is information about businesses. In the case of North Star or the Wave software we just looked at, it's dynamically coding spatial data relative to automobiles. And where those automobiles, we call it geocoding, when we geocode that information on the topology and place it in a particular location. You can have geographic information systems relative to buildings. Hospitals use them for maintaining and tracking their staff and locating them so that they can be accessed and retrieved for, in case of emergencies. Companies like John Deere, again, and Caterpillar, and other large earth-moving equipment companies and farming equipment companies incorporate GIS into their steering control systems of their equipment, the more sophisticated ones. Transportation firms such as trucking firms, shipping firms, use geographic information systems for purposes of planning routes. UPS used a geographic information system about 5 or 6 years ago to design routes that minimize the number of times that a driver, when driving on their route, actually had to turn left. So they designed a route that minimized the left-hand turns, this was it saved the company millions, because turning left means you have to cross 2 lanes. Turning left, if you minimize those, it means you've reduced the possibility of collision by about 50% statistically. Google Maps incorporates geographic information systems for mapping, so does MapQuest. Google Maps, of course, integrates photographs. They used to spend lots and lots of money capturing those photographs. When they bought Waves, Waves actually has a photograph sharing type arrangement with their users, and users provide photos of locations. So that integrating Waves technology into Google's GIS technology enabled them to reduce the cost of those photos. But again, you want to deliver location-based services, you got to have a map. You got to have encoded data, geocoded data on the map. So in the case of Uber's data, that dynamic data that's encoded on the map is the location of all of their drivers, as well as the location of those seeking services. Those seeking transportation services. And of course, the software does a good bit more than that, but again, it pinpoints the quickest resource, matches them up, and then make that service is delivered. And of course, now they've been adding some additional features since that issue they had down in Columbia with that young girl was killed because she thought it wasn't an Uber car. I haven't used Uber since then. I'd read they've updated the software for verification purposes to give some additional information about the automobile. So, for example, you see the tag number, you can check the tag to make sure it's the car. Radio frequency ID, we've talked about this. This is a digital barcode. So it uses radio waves. You use radio waves to read it. There are both active and passive tags. An active tag has a power source, and a passive tag does not. A passive tag uses the energy of the signal. The active tag is going to tend to have probably more storage capacity. The active tag is going to be more expensive. You tend to see active tags on like shipping container units, pallets, where you've got kind of summary information about all the boxes on a pallet, things like that. Passive tags are the cheaper version, and assuming that the cost of the tag is not a burden, an impedance on the profit of that item, televisions, for example, it's very appropriate to put radio frequency ID tags on televisions. You can use these to track the device as it propagates throughout a supply chain. You can change content. RFID tags have two advantages over two-dimensional barcodes. One is stores a lot more information, not just a 12-digit UPC number, although there are multi-dimensional barcodes that can store more. But the other thing is that you can change the content. You can change the information on the tag. You can't change it on a barcode. You've got to replace the barcode if you're going to do that. So you can, and of course, the last thing is you can read the content wirelessly. Line of sight is not essential. You don't have to have line of sight in order to read it. And you can read it from a fair distance, as a matter of fact. So just a few innovative uses of RFID. Vets are using them with animals or pets, anti-theft systems for automobiles. There's a company called Escobar in Brazil. Excuse me. There's a company in Brazil, and they've got about 1,000 parking lots, and so they are using as a checkout device. When you drive through the gate, you have an RFID. It scans you in, and when you exit, it scans you out and debits your checking accounts the appropriate amount, or credits your credit card account, whichever one you use. So that's an automatic payment system. Managing inventory, again, the cost of RFID is coming down. If the inventory is a bar of soap, it might not be appropriate. If it's electronic devices, it should be okay. You know, the more expensive it is, the more you want a technology that allows you to really, really control that device. Because with an RFID tag, you could have a system of readers located throughout a facility. You can track that device wherever it moves, even if it doesn't have line of sight. So cooking robots, I saw this on television one night. They put RFIDs on the equipment in a kitchen and had robots cooking, and it wasn't just equipment. They had RFIDs on the vegetables too, and the robots were just using that, and they'd go through the appropriate procedure and create the dish. It was some kind of baking dish, as I recall. Disney uses RFID technology in its Magic Band. These allow you to, they've got a fast pass. They've got, you can have photos taken of you. You can store your credit card or debit card information. So the Magic Band actually has an RFID chip. It is an active chip, so it can be read from afar. It has a 2-year battery in it. It connects you to a vast, powerful system of sensors. It does replace most, if not all, of the paper processes in Disney. It is, again, linked to your credit card for ease of payments. And they also observe what you as a guest are doing on a daily basis, and they use AI software to analyze that information. The goal, of course, with Disney is to kind of anticipate, which rides are more popular, which are less popular, what's going on, where they're doing well, where they're not. So, wireless technology certainly enhances mobility. And I would remember these. What are advantages of wireless? It enhances mobility. It provides immediate access to data. So, if you're in the warehouse way back in the back and you need access to the location because right now the system's telling you that something is here and it's not there. So you need to use an alternative system to find out where that information was. Or you need to go into the inventory management system in the history and see if it was shipped or if it was at another location. You're using maybe dynamic inventory storing. It does increase the ability of companies to locate and monitor someone. That's a kind of a double-edged sword, but it's invaluable to customers who are seeking to deliver, again, those personalized services, because location is one of the ways that you can personalize things. It does improve workflow. Again, if I've got salesmen out in the field and they leave a customer, they go to the coffee shop downstairs in the building that the customer was in, and they sit down, they have access, wireless access They're offering Wi-Fi services. They set up a VPN and they enter in the sales data, and so that triggers that activates all kinds of activities related to that sales order. Instead of having to wait on that customer maybe to make it back to the hotel room where they got a data connection, or maybe even back to the office. It is an alternative to wiring. It has its advantages and disadvantages. Advantages obviously are all the things that I mentioned, mobility. Disadvantages are security. You got a wire that's just right out in the middle of anywhere. So you have to take the appropriate security measures, particularly if you're talking about corporate access to systems. Mobile business opportunities. When mobile became reliable, when the bandwidth in mobile achieved a certain level, we started seeing everything from video conferencing over phones to services like Uber and Lyft. And it took you had an amalgam of things that occurred simultaneously. You had the growth in wireless bandwidth, but also the evolution of the smartphone, as well as tablets and laptops that can access via wireless networks. So again, the extension and enhancement of mobility, complemented with the systems that use it, have really evolved and presented new opportunities for business. Challenges, again, it's a mobile device. I can remember a number of cases where involving corporate espionage or government espionage where someone lost a phone or a laptop and that device actually had critical information related to maybe military operations or product development, and it was lost because the devices were mobile and they were not in a secure area. Protecting wireless connections requires encryption. You want to use WPA2. Wireless Protection Access, WPA2 is the latest standard. If you have a device with an operating system, someone will write, and that operating system is popular, someone will write software that operates as a virus, because viruses deliver payloads. The viruses can, for example, deliver malware, and that malware can, say, for example, capture that device, use its processing, use it for illicit activities, say, for example, spamming, that is sending unsolicited emails. Privacy concerns with location-based services and RFID, and that is that we have these mobile devices. There's tremendous upside, but it's also tremendous risk in the fact that data is almost free data storage. And now you have these devices that not only we volunteer information on them when we interact with a website, when we purchase something and contribute information necessary to complete a sale and have the product shipped to us, but also we may not be aware that whatever application we're using may also be tracking our geographic location and sending that information back. Google, for example, most certainly is. So Google most certainly is tracking your location. So if you have GPS enabled, Google is capturing that information, where you are during the day when you engage in whatever activity. So those are challenges. So recognize them. And that completes Chapter 16 and completes the material we're going to cover for this class. Now, I have updated, and I need to correct an error on the exam. You'll see that the final exam is on Wednesday morning at 8 o'clock. It's going to be in room 250 here in the George. You also can schedule it between the dates of April 29th and May 2nd. So you can actually take it on Monday, even though Monday is the last day of class, actually, technically, but I will let you take the exam on Monday if you would like. I would only do that if I was pretty confident of how I would do. The topics list is here, and you'll see what's wrong when I click on one of these links. I think if you click on one of these links, it gives you an error 403, and it's not giving me that error because I am actually logged into Prezi. So let me log out, and yeah, I'm going to log out, and I'll show you what it's doing. I will correct this evening when I get home. So I'm going to click here, and there it is, restricted space. It's an old URL. They changed something, and they made the existing URLs non-existent for some reason. They did it over the I don't know, the fall holidays, so I'm going to have to go in and update all the links. But I will do that this evening. Again, this is the topics list. You know, the only thing new that we've added has been the wireless, so you have video reviews of all the other topics. The one thing that I would offer for the final exam is the final exam is more general in nature, so the questions tend to be more general. So it's more allowing, here's a description of a technology which applies. And I kind of view my in-semester exams as my opportunity to ask for more specifics. It does not mean that you will not have some specific questions. It just means that in general, it will be more of a general. There will be more of a general question approach. The format will be the same, true, false, multiple choice, and there will be a short answer, and you will be given a choice of, 7 of 10 or 8 of 11 or something along those lines. So, any questions? Okay, hearing none. Last thing I wanted to mention. I offered this to my day class, so I'm offering it to you, and I will post the announcement, but I've got those of you here, so I'll let you know. I was informed by the Office of Academic Affairs that I had low participation rates for my course evaluations. And so I'm going to bribe you a little bit, if that's okay with you. I will offer 3 points. A 3-point, I will add 3 points to the exam. Usually I will tell you, I do curve the final exam for this class a little bit because it's a little different when you're sitting in a classroom and you don't have access to materials. I'm well aware that students access materials as they're going through my exams. You will not have that ability when you're taking the exam in a classroom or in the testing center. So I typically look at all classes, and then I use something called a variable curve, which means I take whatever your total points are and I multiply times, TP stands for total points, and I multiply it times 1.1 or something like that. And then I will add 3 points. If, and this is the criteria, I have to have a 70% class evaluation participation. So if enough people go in and do the evaluation and I get the number to 70%, then I'll add 3 points to whatever the curve grade is. Okay? Okay, well, I've enjoyed having everyone in the class. I will see you one more time, at least officially, as your instructor next week. The exam, again, is on, looks like Wednesday. It's an 8 a.m. exam. And if you do have a conflict with that, then just, again, schedule it with the testing center. I'll have it set up at the testing center as well as at Greenville that anybody who calls over there, they'll have the entire list of students. That will allow for, anybody who maybe decides they don't want to come take it in the classroom, they want to take it at one of the locations. Okay? All right, well, I've enjoyed having you, and we will see all of you next week. Now, let me go ahead and set up for attendance this final time. And open. Okay. And get plenty of rest. Don't try to cram all at one time. Pace yourself. Also, by the way, if you have, again, I reiterate, if you have outstanding Connect work, if you have 0 grades on some of your Connect work, by all means, reach out to me. I will give you, I will give you an extension through April 29th. You can do that work. It will help you in terms of the exam because basically the Learn Smart lessons are covering a lot of terminology that you'll see on the exam, and you'll get 50% credit. You might not get 100% credit, but you'll get 50% credit, and that's a lot better than nothing. There are 12 points toward your grade in the Connect work, so I do encourage you to even if it's for partial credit, do those. At this point, it's a point. At this time, it is a points game, folks. So you're trying to get as many points as you possibly can. And I would also say, if you look at your SimNet work, and you've got until May when you're scheduling here, you got until May 5th to do your SimNet work. So I think I've looked, and I've got to have grades in by the next Monday. So you've got until May 5th to do your SimNet work. So plan accordingly. But if you've got 0 grades on some SimNet work, by all means, let's do those replacement projects. It can make a tremendous difference. Those SimNet projects and lessons are 23% of your grade. They can bring your grade up tremendously. I was talking to someone today who's kind of borderline right at a 60 right now. But they've got a couple of bad grades in SimNet. If they do those replacement projects, they can easily bring that SimNet average up. And they're going to they made a calculated error in saying, okay, I'm not going to do the Connect work. But, so they're actually 12 points below where they actually should be. They're sitting at 60. They should be at a 72 right now. And it's all because they just elected not to buy Connect. Which I'm not sure how they manage that because Connect also includes the book. So perhaps they had a paper copy of the book. Okay, we'll see everybody next week. Have enjoyed having you, and reach out to me if you have any questions before then.